Okay, so we're going to try this again. If you remember back from the string challenge, I presented you with a problem, and you discovered that problem, and you did some observing, figured out what was wrong, what you needed to do, you came up with a potential solution, and what you did from there after you came up with the potential solution is you tested it. You tested to figure out how you could potentially get out of this predicament, and upon doing that, you did not realize it at the time, but you were actually doing the first few steps of the scientific method. And the scientific method is often described as a series of steps. Hopefully this pen tool works. Okay, that's a series of steps, and we use it to answer a question and solve a problem. So just like in the string challenge, when you're presented with a problem or you have a question that you need to answer, that is what the scientific method does. And there's 6 steps. We have a 6-step process that we use to go ahead and do the scientific method. And that process begins with identifying the problem or the question. Okay, and all that is what are we trying to find out? What are we trying to figure out? So in the string challenges, the problem or the question that we had is how do we get untied from the string? After doing that, we did a little bit of research. And for that, we observe the purpose, or we try to find out as much as we can. We try to find out as many details about the situation as possible. The next step is going to be to develop a hypothesis. And upon making that hypothesis, we make a prediction. A prediction to the problem, or for an answer to the problem that we are currently faced with. So for that string challenge, a lot of you guys thought that by twisting and turning as much as you could, you were going to get yourselves out of that tangle, out of that situation. And so the next step, what you did was you experimented with it. You decided to put your hypothesis to the test, which is what you're supposed to do, and you experimented with it. You tested your hypothesis. After the hypothesis that you tested, after you did your experiment, you went ahead and you did some analysis. And although we didn't sit here with clipboards and write down a ton of numbers, which you would typically think of analysis, you still recorded and collected data. Now, in this example, you just observed. Did it work? Did it not work? And that's where you get your conclusion. And was the hypothesis correct? And I don't think in any case throughout the whole day that any of you were 100% correct with your hypothesis. So what we're going to do from here is we are going to, we're not going to do that, guy. We are going to kind of go through each step very slowly, break it down a little bit. So we're going to begin with the purpose. Step 1, identifying the question to the purpose. So scientists will often ask a question based on a problem that they observe in nature. So from these pictures, you can very obviously tell that I'm talking about the idea of global warming or the idea of climate change. Now, we don't really refer to it as much about global warming anymore. It's more along the risks of climate change. So we're wondering why, some hurricanes may be getting stronger. That's a concern. And so what scientists are doing is they're investigating that. But that is their purpose. They want to find out more about that. The next part is to actually do some research. So you ask yourself the question, what do we already know? And then, of course, what can we find out or discover about your subject to help you form a hypothesis? Now we have all these observations, and this is part of what helps you find out, do a little bit of research. You have to take observations. So these observations can take place in many forms, and I just have a few examples. We've got maybe some length, something that you can measure like that. We've got volume. How about some time? So with a stopwatch, obviously we've got color. We've got shapes that we can look at. We've got temperature. And this last one seemed to give some people a few problems when we were trying to guess it in class, but this is behavior. We can always observe behavior, which will help us understand something further about something we want to know. Give us a little clue. Moving on from there, again, these are observations. We did a ton of these, shouldn't have any problems, but here's the 4 basic guidelines that you need to do whenever you make an observation. It is always beneficial to draw. It is always beneficial to label. It is always beneficial to write down your observations. And finally, you always use the metric system. There's never an exception to that. You are always using the metric system, which is what brings me to this part. All right, no cussing in the sense that we're using bad words, those typical ones that you would think of course we're not going to use those in here. But in this case, what we're thinking about is words that are not considered part of the metric system. Okay, so the inch, the foot, the yard, we're not going to use those. We'll use meter. Okay, we're not going to use anything like pint. We'll use milliliters. Okay, try to stay away from using the English standard words. The next part, the hypothesis. And as we go into our hypothesis, I want you to remember what I said from the beginning, is that a hypothesis is more along the lines of a prediction. Okay, so after your observations, you're going to form that hypothesis. We're in green now. Form that hypothesis. Hypothesis is a possible explanation or solution to the question or problem. It is also referred to as prediction. And this is the big one. This is the one that I want you to focus on, prediction. It is a prediction. And this must be testable by an experiment. Why does it need to be testable by experiment? Well, because if it wasn't, you wouldn't be able to look back at the end of your experiment and say, okay, was our hypothesis correct or not? If you could never test it, you would never know if your hypothesis was correct. Okay, some words that we never want to use in our hypothesis. We never want to use the word you. We never want to use the word I. We never want to use the word believe. You want to make everybody else believe that you know exactly what you're talking about. So you don't want to use the word believe. You don't want to use the word maybe. You're very confident in your hypothesis because of all the research that you've done. Okay, that's a little bit of homework, and we're getting into the experiment now. So after you have written your hypothesis, you must plan your experiment. And this consists of a procedure and a materials list. To create a procedure, you must list the items and then create a step-by-step process that is simple enough so that it can be repeated by another scientist. Okay, so pretty simple here. You're really just creating a list of what you want future scientists that do your experiment to do. Exactly how you did it. You want to set it up. You want to provide this step-by-step process that anybody else could pick up your materials and do. Procedures include many trials. And the reason why? Because it makes it more accurate. More trials makes it more accurate because that's more data to pull from. The more data we have, the more confident we can be about our conclusion. It is important to design an experiment that will show that one factor caused an observed outcome. A factor is anything that will change the outcome of an experiment. Scientists strive to design a controlled experiment that only tests one factor at a time. The reason we like controlled, and what I mean by controlled is I say, if we were doing an experiment that dealt with something that we're going to do this week, if we were doing with heart rates and exercise, something that we would want to control is by leaving it indoors. Now, we may actually go outdoors because of the room and because it will allow us to not necessarily disrupt other people's classes, but if we could have our choice, we could stay inside because we wouldn't want the temperature to affect the results. So that would be keeping it controlled. We're controlling the temperature. The one factor that changes is called the variable. And we have two types of variables. Sorry, my pen tool isn't working very well. And those two factors, those two variables, are the independent and dependent variable. The independent variable is the factor within the experiment that will change. We've gone over this a lot, but I want to make sure that we all understand that the independent variable is the one that changes. This will justify your hypothesis because you will have comparable observations. The dependent variable, this is the factor that will be affected. So every single time you get the question, what's the dependent variable, I want you to ask yourself, what is being affected by the independent variable? This is what will be changed or is the outcome. Okay, moving on, constants. Constants are factors that will remain the same. They do not change throughout the whole experiment. So if we're doing that experiment on exercise and heart rate, the fact that we're staying indoors is a constant because the temperature is remaining constant. We're not allowing a difference in temperature to change our heart rate. The control group is the group in which you will compare your and I'm just going to abbreviate for independent variable again. So that's the group that you're going to compare your independent variable against. In other words, this is the group that does not change and is left alone. I like to think of this almost as saying that it is the normal version of the independent variable. Okay, the normal version of the independent variable. Now these are some of the examples that we did in class, and I'll probably go ahead and do solutions to these, but I'll go ahead and do them on a different video just to kind of get through this one, make sure that everybody is good to go with these. I'll go ahead and clear these for now. We're on to the collecting and analyzing data. Okay, and here, as the experiment is carried out, you must figure out a way to, let's change colors here, figure out a way to collect and organize the data. Some ways you can do this. Graph. Okay, you see a nice version of a graph right there. You could chart. How about make a table or a diagram? Okay, guidelines for our data. You know, the first thing that you need to know is that you always need to provide a title and label to your diagrams and graphs. And a title shouldn't be something really basic. If we're trying to show everybody what flavors of ice cream our class likes, then we can't just say the title is ice cream. We have to tell exactly what it is. So a great example would be the preferred ice cream flavors of Team 3. That would be a great example of a title. Now, the measurements should be specific and have the units labeled. If you look at my example of a graph over here, you can see that it has the part that says in inches. It needs to include inches. The units are labeled. Because if we look at that and it says, okay, water, the average height of plants that were just grown with water is 6. Well, that could be 6 feet, could be 6 meters, could be 6. In our case, it's inches, and we need to know that. Should be in centimeters because we always use the metric system, but however, for this case, they went ahead and used inches. You need to make claims and provide evidence. A claim is a true statement. Claim is a true statement from your experiment. Okay, so what we'll do is there'll be sections on your labs that ask you to make a claim about your data. So if you're looking at this data right here, if you're looking at that data, and let's say that the water stopped about right there, the Peter stopped there, spectrum there, and that one there, then you can go ahead and say that, well, Miracle-Gro very clearly had the highest growth, or the highest height of a plant. That's your claim. You're saying that Miracle-Gro had the highest height of plants. When you go ahead and you provide the evidence, you can say, well, it's because our test results showed that water had 2, Peters had 2, Spectrum had 2, and Miracle-Gro was up around 7. That is providing a claim and evidence. Okay, and here's the final step, the power conclusion. And after the analysis, you always want to draw a conclusion. And these are steps. This should be written in paragraph form. And the way this works is you're going to begin your first sentence by saying, the purpose, and I'm even going to write this up here. The purpose of the experiment is to ... couple of dots there. The purpose of this experiment is to do what? So that's step 1, is to restate the purpose. After that, you need to use some details from your data to answer the questions. So the purpose of that experiment that we were explaining on the last slide about the growth from plants and the fertilizer, use some details. Say that Miracle-Gro had 7 inches on average of plant growth. But just make sure, or say that your details could be to say that Miracle-Gro had the highest growth. But then you need to back that statement up by saying that it grew 7 inches, whereas everything else grew around 2. After that, you need to refer back to your hypothesis. Go ahead and state whether or not that hypothesis was correct. If you were correct, good. You confirmed it. If you were incorrect, that's okay. Just state it. Explain in scientific terms. Now, I'm not too worried about this one because you guys are already pretty good at using scientific terms. The only thing I don't want to hear or see is that you're using the term thing or something along those lines. Use your scientific terms. Finally, explain what possible errors. So like I used the example in the heart rate lab. If we were to go outside and maybe the temperature was really, really hot, that could be a potential error. Some people react differently to heat and their heart rate could rise. And the last thing that I want you to take a look at is right here, and I'll start again. You are literally going to write the exact same sentence last as you started off with. And that is your conclusion. And that is also the conclusion of our lesson. If you have any other questions, feel free to ask me in class. Otherwise, I hope this video helps.